Good day, fellow. So is back. Today we are going to continue with ionic compounds, to be specific, of transition metals. Ionic compounds of transition metals. Transition compounds. Transition metals, sorry. To be specific, we are going to write the chemical formulas. I'm going to give you a name. Then you as a learner must write what the chemical formula of that given ionic compound. Then now we know that from our periodic table, here I do have periodic table, that all metals that are situated somewhere inside this box, I've marked inside this box, we call them the transition metals. Their ions vary by time. I hope you have came across in your life something which look like this: copper plus, or copper plus 2. You see, it's the same copper, but now its ion is not the same. We have +1, we have +2. You see, we call such the transition metals. Then this one is going to be copper 1. Then this one is going to be copper 2. We use Roman figure numbers to represent the ions of each and every element for transition metals. If we continue by saying, if let's say we were to continue by saying copper 3, we would say now this one is going to be +3. You see, as a learner at this point, you must know your Roman figure numbers, because you still remember that this is 1, this is 2, we have 3, we have 4, 5, we have 6, we have 7, we have 8. See, so simple. Then this is our Roman figure numbers. Suppose if, let's say, they give us something which is like this: copper 2, let's say sulfate. Then they ask us to write the chemical formula of this given. Do you still remember that sulfate is an polyatomic ion of SO 3 minus 2. Then for copper 2, you must write Cu with +2. You see, I've already written it there. Then at this point, you can then now do what? Use a cross method to say, now I have 2 this side, I also have 2 this side. Then it's going to be Cu2. Then don't forget to open bracket for polyatomic ions. You write 3, then it's going to be 2. At this point, we can clearly see that we have 2 and 2. They cancel each. Then it's going to be 1, 1. It's like if I divide 2 by 2, I get 1. 2 by 2, I get 1. You see, if you have same numbers of ions, this side is +2, this side is -2, you normally do like this. Immediately after doing like this, they will eventually cancel each other. Then it's going to be CuSO3. You see, suppose if, let's say, now they say write of copper 1 sulfate. How are you going to do this one? You do the same. You apply the same principle to say now copper is Cu plus 1, sulfide going to be minus 2. Then you cross this, you cross. Then Cu is going to receive 2. Then you open bracket for this one. It's going to be 1. We know that 1 doesn't affect anything. At the end of the day, it's going to be SO3 with Cu2. You see? Now, how are you going to write this one? Let's say if by chance they give us iron 3. Let's say if they say you have iron 3 somewhere there, and let's say carbonate, iron carbonate. Do you still remember the polyatomic ion of carbonate? It's SO3 minus 2. Then ion 3. By these Roman figure numbers, we know that ion is going to be our transition metal, which have its ion Fe plus 3. Then how then now are you going to write your chemical formula at this point? You do the same method, but don't forget to open brackets for your polyatomic ion. Then it's going to be CO3, then you close. Then it's going to receive 3. You write 3 over there. Then just next to Fe, you are going to write 2. Then it's going to be Fe2. You see? Then this one is going to be our chemical formula for what? For iron 3 carbonate. You see? There is no need for us to divide 3 with 2. You see? Because 3 is not an even number. You leave it as it is. You see? At this point, we divided 2 by 2 to get one of this as well as one of SO3. SO3. You see? It's so simple at this point. I hope you understood it. Then I thank you and enjoy.